Assalamualaikum and good day. My name is Hamizan bin Nazarudin. This is my final year project video submission. I am supervised by Associate Professor Dr. Hirofumi Hara and also co-supervised by Dr. Nadia Farhana Binti Azman. My FYP title is Evaluation of Nanotechnology for Antiviral Activity. Okay, so let's start with why I took this topic is because myself I believe that the level of pollution is so high in current environment, and I found out that it's especially when it comes to the air pollution, so much so that the composition of the air has changed by the addition of the pollutant, and hence people are taking interest in staying indoor because indoor air surrounding is indoor air environment supposedly separated from the surrounding air because of the limited and confined spaces. But the thing is, the truth that due to domestic activities, there might be a new source of pollution inside the indoor, hence not necessarily cause safe condition per se, because for instance there's heavy metal from lead in the paint, aerosol from cleaning supplies, and also the microorganisms that thrive in our living spaces. And especially since the start of the pandemic, uh, the concern for having clean indoor air has risen because uh, public can't go outside and they want a guarantee that their indoor air environment is safe from any microbe. Hence, my problem statement is improve indoor air quality using improvised technology. The technology that I'll be looking for research on is called nano EX technology from Panasonic Corporation. The nano EX is said to be the solution for indoor air pollution through the generation of OH radical. So what is OH radical and why is it important for eliminating or reducing pollution? First, the OH radicals said to have the capacity to inhibit microorganisms, not just any pollution, whether it's volatile organics, particulate matter, but also microorganism that is very uh, concerned during this time, especially of the pandemic. And the OH radical, the nano EX, said to have able to generate high concentration of OH radical. Hence, the radical could disperse throughout the indoor air and hence become more effective in eliminating the pollutant. Also, the nano X has increased the life expectancy of OH radical because currently OH radicals could degrade simultaneously after the generation, but nano X technology could increase it to up to 10 minutes. And also, nano EX have high application capacity. That means that it could be installed in multiple devices, not necessarily just to be the air purifier. So, as for this research, my objective is to determine the dye decolorization by observing the absorbance through UV vis spectrometry after the exposure with OH radicals, and also to observe the growth of microorganism after the exposure to the radical. And my scope here is using the UV ultraviolet visible light spectrometry to observe the colorization by absorbance, also as using bacteria as aureus as the airborne microorganism. So the methodology first is the dye degradation, in which dye of the methylene blue is prepared for 100 milligram per liter solution and then diluted to 80, 60, 40, 20 milligram per liter solution, in which there's two parts of the dye degradation experiment. First is with the addition of propanol, which is the scavenger. This means that the addition of scavenger will inhibit the reaction of OH radical, and also without the scavenger to see the actual reaction of OH radical. And then the both sample is then exposed to the device that generates OH radicals, and after a period of 5 minutes, 10 minutes, and 15 minutes, we then see the result through the UV vis spectrometry, and the corresponding concentration is determined by the absorbent observed. And the second part of the experiment is bacteria exposure, where the bacteria S. aureus obtained from the lab is inoculated into the growth broth, which is the LB broth. And then we also prepare growth agar, which is the mannitol salt agar. And from the LB broth, with containing the bacteria, it was further diluted so that the end or the sample that we use in the experiment contain only a little bit of the bacteria so that we can observe the growth. And then the sample bacteria that was diluted is used in the experiment. There's two parts of it. First, we expose the mannitol salt agar to the device, and the next is we take a little bit of the bacteria that was diluted, pour it and spread it using the streaking method onto the plate, and then expose. And then for the agar, exposed agar will then be spread with bacteria, and then we incubate both sample overnight at 37 degrees Celsius, and we then count the colony grown on the agar. So the result. Firstly, the first result is on dye degradation. This is the result from exposure with propanol, the scavenger. So we might know. From it, we can see that on 5-minute exposure, the highest or the maximum reduction degradation percent is at 100 milligram per liter, followed by for 10 and 15 minutes is at 60 milligram per liter. By which we could conclude that the maximum capacity for the device to degrade methylene blue dye is at only 60 milligram per liter, and it was assumed that it was concluded that the result on 5 minutes is obtained some error, because from the result we see that the corresponding concentration on the control for 100 milligram per liter only correspond to 60 milligram per liter of concentration. And then we could see that from this, the trend at the lower concentration before the maximum degradation of which is the 20 milligram and also 40 milligram per liter, you can see that the trend increase over the time. The 15 minute have the highest degradation rate compared to 5 minutes, which have the lowest degradation rate between the periods. And next, also we do the second part of the dye degradation is we introduce another set without the addition of the propanol, which is the scavenger. And for the 5-minute 5-minute result, we could see that as mentioned before, with the propanol, the maximum degradation is supposed to be on 60 milligram per liter, but without the addition of propanol, it was found to be 40 milligram per liter, which is actually contradict with the literature, because the function of scavenger, the propanol, is to inhibit the activity of OH radicals, so it's supposed to have a lower reduction percent or degradation compared to without the scavenger, in which we could infer that there could be either the device producing too much of OH radical that scavenger might not necessarily able to compensate that, or there's another reaction involved with another radicals that actually degrading the dye. As for the bacteria growth, as mentioned, we first experiment we exposed the agar directly before we spread the bacteria and left it incubate, and also we spread the bacteria before we expose it with the agar. And generally could find that the exposure does impact the bacteria growth, in which after exposed the bacteria uh, uh, grow at a much lower population than without the exposure, and it seems that the exposure on the agar directly before the bacteria have much more significant impact, because as you can see here, the control without the exposure on the agar, the growth is unable to be determined because it was too much of a bacteria colony, but after the exposure we could count for it to be 30 and 29, and it was found that by exposing it longer for both experiment, the bacteria growth is much decreasing. And for the conclusion, uh, as mentioned before, according to the objective, the OH radical have the capacity to degrade dye, but it was limited by the capacity of the device. So much investigation may needed. And for the growth of bacteria, the radicals have high potential to reduce and inhibit the growth of microorganisms. And from the experiment, we could conclude that exposure on the growth medium is much more efficient than directly impacting the bacteria. And for further research, I would recommend experimentation on other types of microorganisms such as fungi and virus. Also, characterization study to identify the actual species of radical or other gaseous species involved. Also might be investigation on different scavenger to further inhibit the reaction of the radicals, as well as the comparison study with other purification methods, for instance, ozone water. And that's it for me. Thank you for listening, and thank you for your time.